So we're gonna see whether this works or not. I'm really excited. This shall be my first live stream. Yes. Okay, so hey folks, welcome back here on Catching Photons. And today it's all about the Great Conjunction. Same thing as yesterday. It's wonderful weather, clear skies, and I already found Jupiter and Saturn with my Planetary webcam. So, hi. I need to set something. Wait a second. Okay. Okay. Right. So, what do we have? We have the Great Conjunction between Jupiter and Saturn. And right now in the field of view, you can see Jupiter in the top right corner, and Saturn is a bit dim in the bottom left corner. I increased the exposure time so that you can see the rings of Saturn. See that? Wow, beautiful. And if I increase the exposure time even more, we can see moons of Jupiter. Wait, I pimp up the gain. Okay. All right. So, hi. I need to re-slew my telescope. Wait a second. So, all right, and yeah, if I increase the gain just a little bit more, there you can see the moons. 1, 2, 3. I can see 4 moons of Jupiter. The fourth moon is a bit down. It's in the bottom third of the image, and I just need to configure something. Okay, so because today's the 19th. Okay. Which country? I'm from Germany. I hope the live stream does work. Yeah, we're gonna play around with the exposure time. Same thing as yesterday. Because of the dynamic range of the planetary webcam, we can't see the two planets with reasonable exposures in one image. So we can either decrease the exposure time. Wait a bit. See that? And then we see some cloud structures of Saturn. I'm gonna zoom in on Saturn. Wait. There on Jupiter, I mean. There you go. So this is Jupiter, and it's very wobbly, blobbly, blob, whatever. But you can see some band structures within its cloud. Yeah, the great belt is barely visible. I think we can do a quick capture of 2000 frames just to have a reasonable picture of Jupiter that we can stack afterwards. So I have 100 FPS. That means that we take 100 images a second, and then a camera will sort out those images and we'll take just the best images to stack that. So, and now I'm going to drastically increase the exposure time and we're gonna search for Saturn. Look at that. Okay. So this is Saturn. I try to compensate for a good exposure time, something like that. Yeah, okay. Let's see. Give me 2000 frames from Saturn as well. So this is cool. Hi from Istanbul. Hi. Yeah, great to see you. So this is a cool thing to do with a great conjunction. You don't need to move the scope around. You just increase or decrease the exposure time and you have everything within this frame you want to see. Saturn or Jupiter. We can try to see... No, we can't see the moons of Saturn just yet because it's way too bright. The sky is not really dark. Yeah, do so, Burak, do so. It's such a great sight. Do you use a camera or do you just watch them visually? So you can't see the moons right now. That's just not possible because it's way too bright outside. Whatever. Look at that. In this field of view we have even some moons of Jupiter and a reasonable exposed Saturn, so we will take another 500 frames. So this is one cool thing you can do within a great conjunction, but it's not everything. When the capturing software, I use SharpCap Pro. Yeah, it's done. Captured 500 frames. Cool, cool. I'm going to reslew the scope. Wait a second. Okay. You can do something else. Look at the distance between those two planets. Okay? So they're... I can barely see them in the night sky with a naked eye. In the evening sky. Yeah, but if you look at the distance between those planets, and now I will show you the image from the session yesterday. Look at that. Wait. This was me yesterday. And you can clearly see that the planets are way further apart from each other. And it's not even 24 hours ago. Wait a second, see that? So this is a really cool thing to do. You can actually see the movement of the solar system. So the distance between those two planets comes from the movement of the planetary bodies. So Saturn and Jupiter are both moving. And I mean, the great conjunction means they are like directly next to each other, but just from our perspective. But in reality, they are very far apart. But they just happen to line up with the Earth. So Earth, Jupiter, Saturn seems to... If you can draw a line through all three of them. So, and this movement is visible just from our perspective. If we take an image yesterday, this is the image yesterday. And this is the image today. And you can clearly see the distance changed. So I think it's so cool that you can see the movement of the planets just from our backyard. It's so amazing. So, yeah. Okay, so the YouTube is warning me that the bit rate of the stream is beneath the obligated bit rate. I hope it's okay. I hope you can see me and hear me. Burak obviously can. That's great. Yeah, so okay. So we can use a great conjunction on 2 different days if we are lucky to have good weather on both occasions. And we can make the movement of our solar system visible. And on the other hand, we can just play around with this exposure slider right here. And we can take images of Jupiter like this. And then I capture, let's say, 1,000 frames. And afterwards, I will increase the exposure time. And are you filming during the day? Yeah. So the sun already set. Yeah, I got it. Yeah. Hi. Great to see you here. Yeah. So it's evening. It's not quite dark. So it's a really beautiful sunset, actually. And it was quite tricky to find the planets because is the capturing software ready? Yes. It was quite tricky to find the planets because it's so bright and you can't see the planets with your naked eye. And my telescope behind me, there, I have the Planetary webcam attached. And I have the guide cam attached because I really would love to do some deep sky imaging this night because it's clear. But I can't attach the finder scope. That's a little scope that enables me to see things and get them into my field of view, and the guide scope at the same time. So that's just not possible. And so I can't look through the guide scope. And hi. And so I did some guessworks. I pointed my telescope. I like aimed it to the moon, and then I just moved it to the right. So that means westwards. Yeah, to the west. And yeah. And I just fiddled around, and accidentally I found Jupiter and Saturn. So yesterday it took me like over half an hour to find them. It was very hard. But this time I was lucky. It was just like 5 minutes. And the telescope, the main purpose of the telescope is not only to magnify the image, but also to gather light. So, and as long as the planets are brighter than the surrounding background, the rest glow of the sunset, as long as this is given, you can see the planets within the telescope. That's really cool. So I can increase the exposure time a bit. And so this is the actual color of the sky right now. And you can see Jupiter and Saturn with the naked eye. But Saturn is very, very dim. Yeah, I'm really lucky. So the weather forecast was like all rainy for the next 1 or 2 weeks. And just yesterday the clouds parted and it stayed clear until this evening. And it shall rain tomorrow and all days from from now on. And yeah, I'm really just really lucky. It's really cool. So I had the same thing with with Mercury passing in front of the sun's disk. It was all cloudy like the whole day, and just like 10 minutes before Mercury passed in front of the sun, the clouds parted, and yeah, that was really great. Okay, back to the planets. So I will shrink my image back because you're here to see the planets, aren't you? Okay, we gonna have a look at the planets close up. Okay, so I crop the region of interest, and there's Saturn. There's Jupiter. Look at that. You can see 3 moons of Jupiter very clearly. Oh, there's the 4th moon. Look at that. That's marvelous. I'm going to capture that. 4 moons, and with Jupiter and the moons, it's the same. It's you can not only see the movement of the solar system by comparing yesterday's image of the Great Conjunction with today's image, and you see the planets closer together than yesterday, but you can within one session already see the movement of the moons around Jupiter. That's so cool. I really love that. Yeah, Ethan, I wish you the best. Hopefully the weather stays with you. It would be so cool. Yeah, I'm using SharpCap, and I highly recommend using SharpCap. It's such a mighty program. I really love it. And I bought SharpCap Pro because it has so many features you never want to miss again if you use them. Yeah, it's so cool. The best feature within SharpCap Pro is definitely under Tools, the polar alignment. Polar alignment within SharpCap Pro, I don't know. This is just the best tool. There are other methods to polar align, but polar alignment with SharpCap Pro is it's so easy, and you do it within a matter of minutes, and it's just great. I can't do astrophotography without SharpCap Pro anymore. It's just great. I hope the connection stays with me. So internet connection is not the best where I live. Okay, it seems to work. Oh, just fine. Okay, so there are the moons of Jupiter, but we want to have a look at the moons of Saturn as well, don't we? So this is Saturn. Hi, boy. Oh, Saturn is just such a lovely planet. It's so great. Okay, let's see. For viewing the moons of Saturn, we need to increase the exposure time again. But really, folks, I think it's just too bright outside. It's still too bright. So this is what I meant. If the ambient... Yeah, you're welcome. If the ambient glow of the evening sky is brighter than the glow of the moon, you can't see anything. It's just not possible. Okay, so I think in the upper third of the image, you're just barely able to see Titan, maybe, if you watch closely. But yeah, it's not really visible yet. So we go back. There we are. Okay, this is a very lovely image. Okay, once again, we can see the movement of the solar system within a great conjunction. So I will change between today's view. These are the planets we can see today and yesterday. You see that? It's the same telescope, it's the same camera, it's the same field of view, everything is the same, just the planets themselves moved. And today, I think it's so great. I really love it. Look at that, once again. So, I'm gonna show yesterday. And today. And you see how the planets moved. Okay, I need to re-slew my telescope. Wait a second. So, why do I need to re-slew my telescope? Because I couldn't polar align properly. As I told you, as set up in the evening sky, it was very bright, and there was no possible way I could see Polaris through my telescope yet. So I just guessed, and that was the best I could do. The telescope does track the night sky. It's an equatorial mount. Skywatcher EQ6R Pro. It's a very, very robust and very, very good mount. But if it's not polar aligned properly, there will be a misalignment between the two axes. It's just the way it works. Yeah. Okay, back to the planets. So we took an image of Jupiter with a right exposure time. Now let's see. This seems to be a sweet spot for Saturn, I think. And then we're gonna capture, let's say, 1,000 or 2,000 frames for Saturn as well. Why do we do that? We can't take an image of all the planets with the right exposure time. It's impossible because of the dynamic range. Right? Because of the dynamic range of the camera. It's just not possible. So we need to take one image with the right exposure time for Jupiter, one image with the right exposure time for Saturn, and then maybe another image with the right exposure time for Jupiter's moons and maybe Saturn's moons. And then afterwards we stack 3 images, one with Jupiter, one with Saturn, and one with the moons, and we're gonna merge them together in GIMP or Photoshop. I think it's not really cheating, isn't it? No, I don't think so. Okay. So that was Saturn, and then the moons. Okay, the moons need exposure time. Exposure time. Yeah, like that. I don't know. Jupiter's a bit bright there. Yeah, we take that. Okay, 1,000 frames with that. That will need some time because we have only like 5 FPS because we have an exposure time of 1/5 of a second, and we 5 FPS is the highest possible rate we can achieve with that. Yeah. I really hope this stream does work. I don't know. I don't really get any feedback here. So YouTube claims that the connection is okay. Folks in the chat, you just could, I don't know, print hi. Can you hear me good? Maybe, maybe not. I don't know. So, okay. There's no answer yet. Maybe, maybe I'm all alone. Yes, you can hear me. Okay, cool. No problem here. That's great. Okay. So YouTube Studio just claims some problems. I don't know. I have never used it before, so I need to do a bit of guessworking here. Whatever. Yes. Yeah. Okay. We took a, what's that? He captured 500 frames for us. Well, we want to capture a few more for the planets to stack properly. So obviously you can hear me, that's great. Okay, cool. And if he's done with taking images of Jupiter's moons, one more time we're going to compare the two images just to see the marvelous movement of the solar system. Okay, whoop. That. All right. So he's done capturing the frames. Not yet. 700,000 frames. Okay. So maybe I can move me over here. All right. Good. Sharp cap is nearly done. And then I need to reslew the scope. And then we're gonna have a look at the planets and compare them. Then we took an image of all three different parts of that image. So Jupiter, Saturn, and the moons. Yeah, great, it's done. So I need to reslew. Wait a second. So how cool is that? Okay, look at that. So now this is the view of today, and this is yesterday's image. Once again, I think it's so cool. Look at that. Look how far they move. Just within one day. And so I just joined. What's happening tonight? Yeah, tonight is the day before the Great Conjunction. Is that? Can you say that like this? So today is the 19th, and on the 21st, it's the Great Conjunction between Jupiter and Saturn, and that means that from our perspective, from our little Earth, Jupiter and Saturn seems to be in exactly the same spot in the night sky. So they're parted by just I don't 1/10 of a degree, something like that. So a fifth of the diameter of the full moon. And this is really cool, and it enables us to do the thing we do right now, to see both planets, Jupiter on the top right corner and Saturn in the bottom left corner, in one field of view. So we don't need to slew or do anything else. We just see both planets, and today is only the 19th. So tomorrow, I mean, well, if it will rain tomorrow, but tomorrow they will be much closer, and the day after tomorrow and on the 21st, they will be like right next to each other. And so that would be cool. And if you have the possibility to capture them on the 21st, you can even drastically increase the exposure time. Not the exposure time, I mean the focal length. So I could add a 3 times Barlow lens to my telescope. That means I wouldn't have 750 millimeter focal length, but I would have 2.25 meters of focal length with the same camera. And then, I don't know, let's simulate that. Saturn wouldn't be like this, but more like this. Wait a second. Okay, so the magnification within your image would increase drastically with a 3 times Barlow, because you increase the focal length, and the area of the night sky you can observe will then decrease, and that means that you have a higher magnification, so to say. And then you're able to spot a lot more surface details on both planets, and that would be super cool. But right now the field of view would be way too small to capture Jupiter and Saturn. That's possible on the 21st, and then you can take a marvelous image of both planets and maybe even the moons of Jupiter and Saturn. Today we need to go with 750 millimeter focal length, but either way we either way can see both planets in one field of view, and this is really cool. So Mans and Hobson Interests says, imagine how fast they must be moving to be able to close the gap by that amount in 24 hours. Yeah, that's the thing that stuns me most. The sheer speed, because we are talking about such a giant system, the solar system, and that they move this distance in 24 hours is just, it's crazy. Once again, I re-slew the scope. Wait. Like that. And then I'm going to show you today's view, like that. That was yesterday's view. And you can see the difference between them. And now you can imagine that within 24 more hours, the distance between the planets will decrease even more. So what can we do else? We can open up Stellarium. Stellarium is a wonderful software. If you don't have Stellarium yet, I highly encourage you to download it. It's free, and it's very, very helpful. And you can see the night sky with great details and high precision. So I opened up Stellarium just to show you what we do right now. Okay, wait a second. I need to tell UBS. Okay, so I hope you can see Stellarium right now. So I don't know what's happening. Yeah, how much closer on the 21st of December? They're very bright, right? Also the consumption. Yeah. Okay, so how much closer on the 21st? I need a feedback of you folks. Can you see Stellarium right now? So if you can see Stellarium right now, this is the view within. Yes, cool. Okay, this is the view within our telescope, or my telescope, the Skywatcher 750mm PDS Explorer. It's a Newtonian reflector, and the ZWO ASI 120 MCS color camera. And you can enter those specifications within Stellarium, and Stellarium will give you a field of view of this system. And this is the field of view today. And Stellarium has also the possibility of changing the date. And so we can answer the question of Itachi. So this is today, and this will be tomorrow. So you see, that was we switched. That was yesterday, and I was just barely able to frame them in one field of view. This is today. It's much more easy. So this is our field of view. This will be tomorrow, and this will be the 21st. And the 21st is the nearest possible date, because on the 22nd they will be farther apart again. Okay, so this is the 21st of December, and then they are very close, very close. And hi there. And then we can rotate the field of view like that. It's very convenient. And I can add additional lenses, and I will add a Barlow lens, a 3x Barlow lens, like that. See that? So on the 21st, the two planets would fit inside my field of view with a 3x Barlow lens and a effective focal length of 2.2 meters. So if you own a Smith Cassegrain telescope, those are telescopes with a very high focal length. They are great for planetary, but you could also do it with a reflector or refractor telescope and additional Barlow lenses. And that would be awesome, because just look how big Jupiter will be in our image and how big Saturn will be in our image. That would be so cool. And if you have the right weather conditions, I beg you, please take an image and post it on, I don't know, YouTube or Twitter or anywhere else, because I'm really eager to see images of the two planets so close. So I hope Itaki answered your question. And we gonna come back to our real life great conjunction here. So back on track. We are now back at the 19th, and you see, if I chose the Barlow lens right now, the field of view would be way too small, and I couldn't fit both planets inside the field of view. Either Jupiter or Saturn, but not both. That's just not possible. Okay. So, but we're detaching the Barlow lens, so we're back. Okay. It's getting cold out here again. I need to resalute the telescope. Wait a second. Like that. And then we increase the exposure time a bit. And one more time, we want to see whether we can see the moons of Saturn. Thereby we increase the exposure time even more. Say 2 seconds. 2 seconds. Crank up gain. Maybe it's dark enough for the moons to show up. No, it's not. So I can only spot one moon of Saturn, and this is probably Titan, because Titan is the brightest moon of Saturn. Yeah, it's way up. If you follow Saturn to the top of the image, then you will find a small dot, and this is Titan. I tried to crop the image so that you know what I'm talking about. It's a bit hard to see because we have an exposure time of 2 seconds. Yeah, that's all you can see of Saturn's moons, either way. But the moons of Jupiter are clearly visible. But not even that. Hi. But not even that, but you also can see the movement of Jupiter's moons. If I crop the area up to Jupiter's, no, that's that's not the right cropping. Okay, like that. Where's Jupiter? Hi, Jupiter. There. So we see 3 moons of Jupiter right now. But at the beginning of this session, at the top edge of Jupiter, there was a 4th moon. And this moon is now gone. So I mean, it's not really gone. It's now behind or in front of Jupiter. I highly suspect that it's behind Jupiter. And so we can't see it anymore. And you can literally see the moons rotate around Jupiter within one astrophotography planetary session. That's a really cool thing to see. So it's been cloudy here. I can't see much. Hopefully it clears up before the 21st. Yeah, that would be really cool. Wait a second. No, I don't need to reslew yet. Yeah, that would be really cool. Because I wish all of you just clear skies so that you can experience this cool conjunction. Yeah, wait a second. Okay. So the planets are slowly drifting out of our field of view again. And I will calmly reslew them out. Yeah. Was not possible to me to control everything from inside. So I need to sit outside and reslew them on from time to time. So that's that. That's the great conjunction between Jupiter and Saturn, and the difference between today and yesterday. Wait a second. And yeah, I want to have a short look at Saturn again, but not for its moons, just for this pretty planet. Look at that. I really like Saturn. Oh, whoa. The magnification is way too high. Okay, let's go with that. Maybe we crank up the exposure time just a little bit more. I mean, we really zoomed in way too far. That's better? No, it's not. What am I doing here? Right, over there. There you can see Saturn. And what we can do, we can try to increase focus a bit, but I don't think... No. You know what? Why seeing went so horrible? There are clouds. Clouds rolling in, and clouds naturally highly decrease the seeing conditions. That's not very fortunate. But either way, I don't know whether you can see that. Wait a second. I will... So, this is my view. This up there. Way that boy there. This is the moon. And over here, right in the middle of this cloud band, there are Jupiter and Saturn. And so either way, they will pass below the horizon any minute from now on. And the lower the planets are in the night sky, the more air is between you and the planets. So there's very much air in this direction, but not so much air up to the zenith. So the lower the planets are, the more air is between you and the planet. And so more air means more air distortion, and the seeing then is not as good as with planets high in the night sky. For example, Mars is right above me, red and shiny, so Mars should be visible quite good, but I can't find it right now because I don't have my guide scope activated right now, so I can't do plate solving and find Mars right away. That's just not possible. Yeah. So I can do one more thing. I can downsize my window a bit, and right now I'm unguided. As I said, I didn't plug in the guide scope or anything else just to keep the system portable. I aimed at Saturn and Jupiter, and the EQ6 tracks the whole thing okay-ish. I need to reslew from time to time. That's okay. Yeah, Saturn is gorgeous. Yeah, it really is. Okay, one more thing. We can have a quick look at the moon, and I think then I will end this session because it's so freezing cold out here. Well, wait. I'm gonna try to slew at the moon. Wait a second. Point and shoot. There we are. There we are. So this was the way I aimed for Jupiter and Saturn. Okay, so and that was the easy part because the moon is so big and the moon is so bright. Um, Next up, moon. Yeah, yeah. So that was the easy part. Finding Jupiter and finding Saturn was quite hard, and even more yesterday because today I just got lucky and it worked. But yesterday it was okay, so the exposure time needs to be reset because the moon is so bright. Look at that. Oh, I really love that. Look at that. I try to fine trim. Focus. Oh, look at that. Folks, that's great. What a view. And then we can do a little tour of the moon. So this is the terminator line. And wow. Look at that. The craters at the edge of the terminator line. So this is the border between daylight and night on the moon. And right, let's say, on the evening craters, right before night or the morning craters right before, right after sunrise. If you can say sunrise on the moon, yes. The craters have these shadows inside, and they look very like 3D-ish, if you can say it like that. And it looks so cool. Look at that. Those plateaus and the craters, it's just lovely. Well, thank you very much. Yeah. You'll live stream tomorrow, all right? I can't promise you that, Dilip. Really, I think it will rain, and I don't think I set up my scope in rainy weather. Can you show us the place where Apollo 11 landed? Do you use the Stellarium website to help track the planets? The Apollo 11, I think. I think it's somewhat right in the middle of the frame right now, but the problem is it's dark there, I think. I'm not quite sure about that, so you can Google that and compare it with the image right now. So maybe you just snap a snapshot of the moon right now and then Google it. But I think it's not in the daylight zone right now. Okay. So, but you know what we could do? We could get out the Barlow lens, attach it, and have a close-up look at the craters of the moon. And that will be the last thing we do tonight, okay? Wait a second. I get out the Barlow lens. So, this is a Barlow lens. It's another lens, and it's placed between the camera sensor and your telescope, and it increases the focal length. Wait a second. Then we need to increase the exposure time. And then we can refocus. Yeah, I think this is the sweet spot. Okay. So here you have the craters of the moon. Look at that. That's beautiful. Wait a second. You see all that wobbling? That is the movement of the air. The movement of our atmosphere. This is our atmosphere wobbling around and bending and twisting the light of the moon. reaching our camera sensor. And this gets magnified the higher the frame rate, the higher the focal length is. So with very high focal length scopes, seeing is more of a concern than that's the wind blowing. Yeah, it's not really the wind. So my telescope is quite steady, but it's the air that moves between us and the moon. And so I did an experiment within my tutorial video about seeing. I did a video about seeing, and if you take a glass of water, a cold water, say it's filled up to the up half, and then you add hot water to it, just a little bit. Pour a little bit of hot water inside the cold water. Then you can see that the hot water and the cold water won't mix instantaneously, and you get layers of different different temperatures within the water mixture. And those layers will bend and diffract the light in different ways. So there you have this wobbly wobble effect too. And this is just the moving atmosphere. And this is why we take image with a high frame rate, because we want to get lucky. We want to capture exactly those moments where the air is calmest. I just capture 1000 frames right now with 25 FPS, and the software will determine whether one image is crisp or not, and will choose only the best images. Not on the focus point. No, it's not dependent on the focus point, but on your focal length. So you have concerns about seeing conditions with planetary imaging all the time, because you're working with a very, very high frame focal length. If you do DSO, you normally choose a much wider field of view. So many nebulas or galaxies are just like degrees across, many times the size of the full moon. And you will choose like a telescope with a focal length of say 400 or 500 millimeter. And so what we see now is a movement of, let's say, arc seconds. And you can't see that within your field of view if the focal length is very short, relatively short, say 450 millimeter. But if you try to capture faint and distant small galaxies, that's DSO photography as well, then you're working with high magnification as well, or with high focal lengths. And so then the wobbling effect kicks in again. And that will smear your image, because then you have also very long exposure times and a long focal length, and then seeing will just smear your image. Whereas within planetary and moon photography, we just can take very short exposures and only use the best frames. But if you want to take images of distant galaxies, then you need very good seeing, because you can't just take the best frames. You need all the added exposure time, the integrated exposure time, you say. Okay, so folks, I'm freezing. Whoa, 1 hour. We had 100 visitors. 10 people are still with me after 1 hour. Yeah, I really enjoyed it. It was my first live stream. I hope everything worked out just fine. And yeah, tomorrow it will rain probably, so I can't be here back showing you the movement of our solar system. That's very unfortunate. But if you have the possibility to capture Jupiter and Saturn together in the night sky, I highly recommend that you do that, because it's such a lovely view on those two planets. And if you don't have a telescope, then go out either way. Like at 4 p.m., that's a good time, or 4:30, or maybe 5 p.m. Then it's dark enough and you can spot Jupiter at southwest direction. And on the 21st, you will not be able to distinguish Jupiter and Saturn, and that will be just a gorgeous view of those two planets. Yeah, that would be cool. It's the Christmas conjunction, and it's Christmas time, folks. So, yeah. I wish you the best, and I will end the stream. I hope I see you here around. Yeah, bye.